Welcome to Lesson 1 of Web3 University. The goal of this section is to teach you how to build a full-stack dApp with a front end that's built on top of React and a back end that is built onto a blockchain. We're going to deploy to two different blockchains, both Ethereum testnet and Polygon. Polygon we're going to deploy to testnet as well as mainnet. The biggest reason we're not going to deploy to Ethereum mainnet is the development costs are a little too high for me to want to just play around and deploy to mainnet. But on Polygon, the costs are still cheap, so we'll be able to deploy onto both testnet and mainnet of Polygon, as well as testnet of Ethereum. If you've never built a dApp before, a decentralized application, or you've never worked with a blockchain, this course is for you. We're going to be starting from square one to get set up and ready to go to be a blockchain developer, full stack. Whether you're just dabbling or you've been in the space for a while as a Web2 engineer and you're just trying to bridge over to the missing pieces of info you don't know in Web3, I'm going to be slowing it down, but if I do talk too fast, whatever you're watching this in, you should be able to slow down the playback speed. And if you need to go back, just pause it, go back, and watch it again. I have a tendency to talk too fast because I get a little excited about Web3. Without further ado, let's get started. So we've got Web3 University up on the screen. And when we scroll down a little bit, we can see some of the partners, and we're going to get started with these three lessons. This is going to be your full stack decentralized app. So we've got the Hello World smart contract, interacting with the smart contract, and then integrating your smart contract with the front end. We're doing this first lesson, and for this lesson, we're going to be doing it using Hardhat. You'll notice that there are two sections in this course on Udemy. We've got one section that is for Hardhat and one section that is for Truffle. These are two different libraries that are tools for developers to use to be able to build, compile, and then deploy smart contracts onto a blockchain. Either one works. I've seen a lot of professional companies using Hardhat, but I personally used Truffle a little bit before I started working with Mint Songs and other blockchain companies. So Hardhat is the Ethereum development environment that I have used mostly. I've also played around a little bit with Truffle. When I first got started into blockchain development, I did start with Truffle. But most professional teams I've worked with use Hardhat instead of Truffle. They're both very similar, just think of it like Google, Apple kind of difference. Two brands doing the same thing. All right, so let's get started with the programming. So Elaine Halpern, giving a little bit of backstory, she is from the Alchemy team, which is the reason why we're going to be using Alchemy as our RPC provider today. I was actually able to message Elaine when our team at Mint Songs was having some issues doing some work with Alchemy's RPC. So one of the things that made me want to actually do this tutorial is the fact that Elaine is out here publishing this. So someone that I respect and someone that's helped me in the industry has put out a course. And if you want to read through it, the link is in the description. Otherwise, let's get started. If you're new to blockchain development, you need learning how to deploy and interact with smart contracts, this guide is for you. We're going to walk you through deploying onto the Ropsten test network. We're also going to do Mumbai in Polygon using a virtual wallet. We will use MetaMask, Solidity, Hardhat, Truffle, and Alchemy. Don't worry if you don't understand what any of that means. We'll explain it later, and then we'll get on to part 2 and part 3 in the later lessons. Hardhat versus Truffle, there are two versions of this tutorial, one with Hardhat and one versus Truffle. They're both development environments for building on Ethereum and have similar functionality, so it's totally up to you to decide what you want to use. Hardhat's the newer kid on the block and tends to be a bit cleaner and easier to use. They also have lots of plugins to make it more customizable. A little bit more context there. Hardhat is the newer kid on the block, and they've got a lot more tools within the environment for us to use. So we are already on the Hardhat tutorial, so let's get started. Step 1, we need to connect to the Ethereum network. There are many ways to make requests to the Ethereum chain. For simplicity, we will use a free account on Alchemy, a blockchain developer platform and API that allows us to communicate with the Ethereum chain without having to run our own nodes. The platform also has developer tools for monitoring and analytics, and we'll take advantage of this in the tutorial to understand what's going on under the hood in the smart contract deployment. Step 1, we need to create an Alchemy account. So if you don't already have Alchemy open, so let's assume you don't, Alchemy, I like to look up Alchemy blockchain. It helps to get rid of the Wikipedia results that'll come up first. And then you should see alchemy.com as the first result. Click on that link to go to Alchemy's website. And once we get onto Alchemy's website, we will log in. And I like to use Google login personally, but up to you. However you want to log in. Whoops, let's get rid of this. Okay. So we'll sign in with Google. Sign in with my personal account. Now we should be signed in. Yeah, we want to use Ethereum, including the L2s. We're just going to call this Web3 University. I wonder if there's a way that I can skip this. I cannot skip this. App name is going to be Hello World. And we are going to be publishing. Oh, interesting. So I guess we're going to have to spin up 3 different apps. We will get started with what the tutorial wants us to use, and then we will add in the Polygon networks later. So I think the tutorial wants us to use Coven. Ropsten. So let's go to Ropsten. Now we'll create that app. We're going to stay on the free plan, and we'll continue. I want to skip this. Continue. Let's go. Web3 University. There we go. All right, we've now created an Alchemy app. We've created an account and an app inside of Alchemy, and now we need to get the API key. Apps, create app. We will have entered a description, select staging and environment. We've selected a network, double check that you're selecting the Ropsten testnet, create app. Your app should appear in the table below. We do now have a Rinkeby and a Ropsten. Ropsten is labeled as testnet, and so now if we click into this, we should be able to see view key, and now we've got an API key. So there are my API keys for the Ropsten test network. So next up, we're going to create an Ethereum wallet. We need an Ethereum account to send and receive transactions. For this tutorial, we use MetaMask. MetaMask is the industry standard. Pretty much everybody uses it. If you don't like MetaMask and you want to use a different wallet, some other wallets I will recommend include Rainbow wallets. I've heard a lot of friends that are in the design space really like Rainbow Wallet because of its UI. It's got a very simple, fun, and clean UI. When you click on the page, it ejects a bunch of rainbows from your mouse, so it's very fun in that aspect. Yeah, so if I click on the screen, a bunch of rainbows pop out, which is really fun for Web3. It's definitely a fun user experience. So you've got Rainbow, and then you've also got Coinbase Wallet. Unlike the normal Coinbase service, Coinbase Wallet is non-custodial, which means that you own your keys, not Coinbase, and you can actually run transactions on a blockchain with it, which is way different from Coinbase, where you cannot interact with a smart contract. So both of those will work. Coinbase Wallet exists on an app on your phone as well as a browser extension, but what I'm going to use is MetaMask. So I just wanted to give you some options in case you don't like MetaMask, but the industry standard is MetaMask. You can just search it, and then you click on the first link, metamask.io, and then it will open up MetaMask, where it'll talk to you about it being, I think, the gateway to decentralized applications, gateway to blockchain apps. So click the download button. I already have it downloaded, so I don't need to download it again. Once you click download, it'll walk you through setting up your password, writing down your security keys, and once you make sure your security keys are put in a special place. Never put them on your phone, never put them on the internet. Put them in like a lockbox or something, because if someone gets your security keys, your crypto is compromised. So when you're setting this up, you're setting up a non-custodial wallet, which is a little bit more responsibility for you. Unlike a custodial wallet like Coinbase, where you're trusting Coinbase to keep you safe. When you set up a wallet like MetaMask, you are taking ownership of your crypto and of your assets like NFTs. So once you get MetaMask installed, then we are going to switch over to the Ropsten test network. So I have my MetaMask logo right here. I'm going to go ahead and click on it, and now we will switch our network over to Ropsten. So now we've switched our network over to Ropsten testnet, and our assets have now changed. I had Matic over on the Polygon network, but over here I do not. So we've now switched our network over to Ropsten. Okay, now we want to get Ether from a faucet. Faucet is a place where you can go to get a crypto for free onto your account. Typically, faucets only exist for testnets because on testnets you're not actually dealing with real money. Ropsten is a testnet of Ethereum, so we should be able to find a faucet where we can get free Ether on the Ropsten network. Oh shoot, I need to plug in my laptop. That is an oversight on my part. I will be right back with a charger. Give me just 1 second. That was silly. All right. Now I don't have where to plug in. Unless I can somehow, I guess I can unplug my lights. Or I'm also not using this middle screen, so I should be able to unplug this middle screen. Sorry again for the delay. Unplug the middle screen, move the top screen up there. Now I should have room for my charger. I do. Charger still needs to be plugged into the laptop. Now we should be good. Okay. Okay, 2 screens now instead of 3, but that should be totally fine for us. Let's turn the camera back on. Okay. So we're gonna go get some Ether from a faucet. I'm gonna click on the link over here for the Ropsten faucet. No, open it up in a new tab, please. Cancel. Don't redirect me. All right, so now we just need to put in our address. So we will open up MetaMask. And then I'm just gonna click, I don't wanna send it to my ledger. I wanna move it to, I guess, my main ETH account. How do I wanna do this? Because I wanna get a private key, but I don't want to corrupt my other wallets. So let's spin up a new wallet, create account, private key exposed. Okay, so I'm gonna make a wallet called private key exposed just so that I know I'm probably gonna share the private key to this wallet later on. Just because I don't feel like chopping up this video and making it more secure, so I'll just spin up a new wallet so that I can get a separate private key. So now that we've got private key, I'm gonna copy the public key, and then I'm gonna put the public key in here. I am a human. You're gonna make me check all the trains. Train. We still want trains. Where's a train? There's a train. Okay. Oh no, faucet queue is too long. Please try again later. Maybe we can't get any Ropsten. Testnet Matic, so we might need to go over to a different testnet. That's funny. Let's see in a sec. Oh, it's not gonna let us. Okay, let's check out other testnets. Let's try Coven faucet, yeah. We'll look up a Ropsten faucet. Ropsten faucet. There's the stuff that happens in Web3. You hit a bunch of stuff that you weren't expecting to hit. Okay, it looks like we might be good over here. Send me test Ether. Request has been added to the queue. This faucet drips 3.3 Ether every 10 seconds. You can register your account in the queue. Max queue size is currently 50. Serving from account. Okay. DeFi Karen, that's very funny. Okay. So let's check our MetaMask, see if we got anything. We are still on Ropsten. I don't want to be looking at Matic. I want the token ID. So what we're going to do is look up Ropsten Ether token ID. Okay. I'm looking for the token contract. But it hopefully would just show up in my MetaMask. I'm just surprised it's showing Matic as my first. Let's try it again. I'm going to paste my address in there again. Send me test ether. Your gray list period is now reset on this IP and address. Okay. Let's refresh and try again. Okay, I'm gray listed. I wonder what this account is that it's listing. Ago. Okay, it looks like this account is sending ether, and it looks like the last time it sent was 9 hours ago. So I'm wondering if Ropsten is actually down. Ropsten network status. Because typically faucets are getting pinged kind of all the time. Ethereum network status. All right, what are we seeing here? Looks like we're just watching ETH in real time. I don't think this is on any of the test nets, so we will go back. Okay. I guess let's see if any blocks are being processed on Ropsten. Looks like we did have a transaction processed 5 seconds ago, so it should be fine processing transactions. I don't think the network is down. The only question is why haven't we received Ropsten Ether yet? Or have we? Okay, next check that we can do is we can go over here and we can search our address. And once we search our address, we can see we have 0 ether. So we have not received any ether from the faucet. So we haven't received any ether from the faucet. Faucet.metamask.io. Okay, looks like MetaMask has a faucet as well. So now we're just trying faucets until we find one that works. Okay, and we should have the private key exposed. Cool. Next. Connect. Error, RPC message, too many requests. Too many requests at the node. Alright, so it's looking like Ropsten is not working. Or it's not going to be... Or it's not going to work for us. 81B, is that right? That's not even our account. Okay, so they're getting too many requests over here on Ropsten. Let's see if the same issue is gonna exist for us over on Coven. So let's look for Coven faucet. Looks like Chainlink has a faucet for it. And they just don't have one for some of this other stuff. Okay, so we're gonna try Coven. I don't need any of the link, I just need ETH. Oh, faucets with their captchas. Okay. Alright, so it looks like this one is gonna be more successful. While we're waiting over here, we're going to go ahead and switch our network over to Coven so we can see it in our wallet once we get the faucet. deposit. Looks like the request was complete, and we should be able to view it on our on the scanner. But before we do, let's switch this over to Coven. And I've got 0.1 ETH. Cool. So I've now gotten 0.1 ETH on Coven. However, so now we need to make some updates. Originally we were thinking we were going to be using Ropsten, but now we're using Coven. So let's make sure that we are on the right app. This one already exists for Rinkeby and Ropsten, but we don't have one for Coven. So we're going to create a new one called Hello World. Description Coven. Environment is dev, chain, Ethereum. We're going to be on Coven. And it doesn't want to let us create it for some reason. Oh, looks like I couldn't name it the same thing. Okay, so now we've got a Coven for development. We're going to go into those details. Okay, so we've now we finally got ourselves some test ETH from the Ropsten test network using the Chainlink faucets. How I got here, remember, is I looked up Coven faucet, and then the first result was here, and it did actually send me some Matic. Not Matic, ETH. Check your balance. Double check your balance. Let's make a get ETH request using Alchemy's Composer tool. This will return the amount of ETH in your wallet. Check out this video on how to use the Composer tool. After you input your MetaMask account address and click send request, you should see a response that looks like this. Okay, interesting. I didn't even know that Alchemy had a tool like this. So we want to use their Alchemy's Composer tool. Composer. Oh, very cool. Okay. So we're going to be on Coven, and we want to get balance, and now we're just going to put in our address. And here is our response. So there was our request, here's our response. Now the question is, how do we use this information? Note the result is in Wei, not ETH. Wei is in the smallest denomination of Ether. Conversion from Wei to ETH is 1 ETH is 10 to the 18th Wei. So if we convert that to decimal, okay, so we want to convert this number to decimal. This is a hex, I believe. Can I copy it? Did I copy it? Okay, I did. Hex to decimal. All right, it looks like we got that, and then if we now we want to take this number and 10 to the 18th, so that means I need to count 18 digits, I believe, which is what it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. If we move the decimal place over 18, then we've got 0.1, which is the same as the balance I see here in Matic, which is confirming that we do have 0.1 ETH. Not only do we see it in MetaMask, we can also confirm it by Alchemy. That's a cool little feature. It looks like we can kind of interact with a smart contract, which is cool. Okay, now we're going to initialize our project. If you have never used a terminal before, on Mac, you're just going to open up Terminal. If you're on Windows, I'm going to recommend the cmdir tool. Cmdir. There are other Windows terminals and command lines, but I've found either cmdir, or if not cmdir, git bash. Both of those are the best command lines I've found on Windows. Yeah, Mac definitely is a better terminal in my opinion. Okay, so now we're gonna go. We're gonna open up our terminal. And this is going to assume that you have a terminal downloaded. So we're going to open up, there we go, terminal. Okay, so let's get a terminal open. There we go. Okay, I'm going to go new tab. We're just going to open this up as a new terminal. I'm going to close these other terminals because I do not need them right now. Clear up some of the clutter, keep your development environment clean. Okay, so now we've got a fresh terminal. We're going to Okay, so I'm in my projects folder. If you do not have a projects folder, when you open up your terminal, you're probably sitting inside of this repository where you see a little squiggly line. And then what you're going to do is you're going to run this mkdir command, which stands for make a new directory or create a folder inside of your Finder. Then you're going to name it. I like to name my project folder projects, and then when you hit enter, that's going to create your project folder. After you've created your project folder, you'll run ls, which stands for list structure, I believe. It's going to list the contents of the folder that you're in right now. And you can see I do have a projects folder inside of the current folder I'm looking at. So I can cd or change directory inside of my projects folder. And as you saw, I just started typing the word projects, and then I hit tab to auto-complete that word. Enter executes the command and changes me inside of the projects directory. Once I'm here, I can see the projects that I have. I've just created, or I guess I didn't create a Udemy folder, so I'm going to make directory and I'm going to make another Udemy. I could have swore I just made a Udemy folder. Guess I didn't. Okay, now I've got a Udemy folder, so I can cd into that. Now that I'm in here, I'm ready to go. So let's see what the next step is. So we're going to make a directory for hello world, and then we're going to cd into hello world. I'm going to name this, I'm going to make my directory called, instead of hello world, we're going to call it Web3 University. And then I'm going to cd inside of Web3 University, and now I'm going to make that directory of hello world. ls, I've got my folder of hello world, so I can go inside of my hello world folder. And once I'm in there, navigate to the command line. Once we're in, we'll initialize our project. If you don't already have an npm installed, okay, so now let's check to make sure that we have npm installed. Check you have npm installed by running npm-v, which should return to you the version of npm you have. If you don't get a version number from npm, there should be a link for Node inside of the description of this video. Follow that description to install your version of Node. You can also check your version of Node with node-v. So we've checked npm to make sure we have the Node package manager as well as Node. You'll want to make sure you have both of those to keep moving forward. Now, we're going to, I guess, just set up a base npm project with nothing in it. So we'll paste that command, npm init hashtag. Npm init instead of hashtag _ yes. Yes. Okay, so now we have created a new project in here. We can see we've got our package.json. Here's how we did it. Okay, that's what happened. Now we want to download Hardhat. So let's install Hardhat with npm save dev Hardhat, I believe is the command. Yep, and now we can verify that we have saved it. Oh, I forgot, npm install. It's npm install, or you can just do the I shorthand if you want. npm I save dev Hardhat. Once we do that, we should have Hardhat added to our package.json. And then we'll be able to actually use the Hardhat command line. while we're waiting on this to load, we'll check one more time over at what it is we're installing with Hardhat. So we can see when we look up Hardhat, go to hardhat.org, we can look around while we are waiting for that install to happen. So one of the things they said is especially cool about Hardhat is the fact that we have this whole library of plugins. So let's take a look at some of the plugins. Looks like we got a plugin for Ethers, for Waffle, Etherscan, Web3, Truffle5, Solidity, Ganache, Viper, Truffle. So we even have Truffle where we can interact with Truffle contracts. And then there's also community plugins, Gas Reporter, Deploy Ethers, Watcher, Contract Sizer. Okay. We've now got our Hello World project, and when we ls, we can also see that we've got this node modules. And if we run hardhat-b, I'm sorry, that's not correct. Now we should be able to run npx hardhat to set up our project. So now we run npx hardhat. And I think we want to create an empty hardhat config. Yeah, we do want to create an empty project. Yep, and that's the right place, so we'll hit enter. Want to add a git ignore. I don't really care about it, so we'll do it. You want to install the samples project dependencies? Yes. And now it's going to set up the project. So once we set up Hardhat, then we'll need to set up a folder for our smart contracts as well as for our scripts. Smart contracts are written in Solidity. These are what we're actually going to be deploying onto the blockchain, both on Covin, I believe is the network we're using now, as well as on Polygon testnet Mumbai, as well as their mainnet. Scripts are JavaScript files. And these scripts are what we're going to use to deploy, migrate, do everything that we want to do to interact with the Hardhat library to actually like deploy our code, compile our smart contracts, etc. We're still installing. Once we are finished installing, all that we're going to do is, again, make directory just stands for create a new folder, and then the name of the folder. So this isn't doing anything special. We're just going to create 2 folders. However long it takes us to set up our Hardhat project. And then we get into the fun part. We're actually going to write our smart contract. And what will be interesting is connecting MetaMask to our Alchemy project. Because it looks like we're just going to be exporting our private key from MetaMask. So I'm glad I'm using a way to connect our MetaMask to Alchemy without having to physically manage our private keys. Get started with our coding. If this is the first time you coded and you don't have any development environment, I recommend using VS Code. It's the same code editor I'm going to use. If you don't want to use VS Code, other options include Atom, Sublime, Notepad++. There are a million different IDEs that you can use to develop your code. It's up to you to decide which IDE it is you want to use. We're going to use VS Code, and I'm not going to go through these setup processes. We're just going to assume you've been able to set this up. So let's now open up our project by running from the same folder, code.slash. This will open up VS Code if you have it installed. If you don't, you might have to manually open up your code editor, but this is how we are doing it. Okay, so now we're going to move the terminal up here so that, or I'm sorry, the IDE up there so that I can use it. Okay. So now inside of the contracts folder, we want to create a new one called new file, hello world.sol. Okay, so now we've got a fresh, empty smart contract. So we're going to navigate to the contracts folder, create a new file, hello world.sol. We just did that. Below is the sample hello world smart contract from the Ethereum Foundation. We'll be using it for this tutorial. So we're going to copy and paste the code. Be sure to read the comments to understand what it does. So the first thing, we're just going to follow what Elaine said, and we're just going to copy this into our file, and then we'll command save, or command S for save. Now let's talk through what's going on here. First line up top is specifying our version of Solidity. The version of Solidity we're currently using is 0.7.3. Next thing we're doing is defining our hello world contract object. So we can see that's defined with the contract modifier as well as the name of our contract, which in this case is hello world. This naming matches the name of our .sol file exactly. We then define an event. Events can be fired to help update people that are listening to our smart contract to be updated when an event happens. So if something happens inside of our smart contract, we can use this event, we can emit this event so that anybody that's listening for changes can update their state. An example of this is our front-end React app. We might want when, what's this doing? This is updating a message. So when a message gets updated, we might want our front end to get notified with the new message so that every time a message gets updated on the blockchain, it will notify our front end application so that the front end application is always serving the latest version of that message. So that's what an event does. It looks like it's going to pass in an old string as well as a new string so that everyone that's subscribed to that message will get a copy of both the old string and the new string. Then we've got a public variable called message, and it's of type string. Solidity is a typed language, so you're going to be including types for everything that you define. You also can put on the keyword of public or private or internal or external. There are a few different there are a few different keywords you can use to define the visibility of your variables and your functions. Public means that anybody can read it, whether or not, and anyone can read it. As simple as that. Less is more. If a variable is defined as public, anyone can read it. Also, anyone can set it. I believe anyone can set it as well. I'm 90% sure anyone can set it if it's a public variable. Similar to class, so next we've got a constructor. Constructor gets run once when you deploy your smart contract. This function gets run when you deploy your smart contract. And that's it. Never gets run again, only when you deploy it. And then we put in the initial message. So for this smart contract, it looks like all that it's doing is holding a message. So when you deploy your smart contract, you'll pass in the initial message so that it'll initialize with that message. From there, anyone can read the message for free. And then there's also this public update function so that if you call this function and you pass in a new message, it's going to update the message as well as emit the event that we defined up top with the old message as well as the new message. Now, we could even, this code all looks good. So now we've read through our smart contract. If you have any more questions, there are additional comments in here. Definitely understand the code before you deploy it on a smart contract, but let's keep moving. Super simple update being called the update function. It stores a message upon creation, and you can update that message by calling the update function. So now we'll connect our MetaMask and Alchemy to our project. So we've created our Alchemy wallet, an Alchemy account, and we've written our smart contract. Now it's time to connect the three. Every transaction sent from your virtual wallet requires signing with your unique private key. To provide the program with permission, we can safely store our private key in the environment file. So we're going to run this .env command. .env allows us to set up a local environment variable file for this project. So we'll paste that npm install .env /save. That's going to install .env into our project, and from there I'm sure we're going to create an env file. Oh, interesting. They repeated this. I don't think they meant to repeat this line. Your environment file must be named .env or it won't be recognized. Do not name it process.env or env custom or anything else. So I think they missed the step talking about setting up this, but it's why you're watching me, is I'm going to work through any of the missing steps. So once this finishes installing, we're going to set up that env file. Okay, Still waiting on that install to finish. And as soon as it does, we're going to add that environment variable file, which is just going to be called .env. As soon as it finishes, apologize for my slow internet connection. Currently in a cabin in the woods of Indiana. Okay, so now we can touch .env, and what that's going to do is actually create our .env file, and we can see that right here is our new .env file. So let's go back to the tutorial. Okay, follow these instructions to export your private key. Let's see what their instructions are. I have my own method, but I'm curious how they recommend exporting a private key. It looks like they're just taking us over to a MetaMask article, so I'm sure I already know how to do this, so just follow me. So we're going to get our private key. So open up MetaMask, make sure you're on the account you want to export your private key of. And then I'm going to go to account details, and now we're going to say export private key. I need to enter my MetaMask password, so I need to get my MetaMask password. MetaMask. Don't want any of you guys to see my MetaMask password, so I don't reveal it. But now I can go back over here to MetaMask. Make sure I'm on the account I want to be on. We go to account details, export private key. Now we confirm, and now I can copy this. Don't ever share this key with anybody. I'm sharing a key in a wallet that I don't care about, but don't ever share your private key with anybody. This is, if someone else gets this information, they can steal anything that's in your account. So if you take this, the key that I'm sharing, and you upload it to your own project, you could have access to anything I've got stored in this account. So if hackers wanted to hack me, they could upload that private key and then steal any of the funds that I have. However, the whole reason I set up a new wallet is that I wanted to make sure that nobody, I don't care what's in this, so if you want to steal the account, feel free. The only thing that'll be in it will be the ETH that I'm uploading in this tutorial. So now we can come back over here. And then we want an API URL as well as a private key. Okay, so we're going to go all caps private underscore key equals, and I think we want it as a string. Yep, and then we want our API key from Alchemy. So let's make sure that we're on our dashboard for our Coven project. And then we want to view our key, and then we want to copy the HTTP key. Once we've copied that key, I believe they saved it as API underscore URL, question mark? API underscore URL. So now we can go, and I'll put it in the same order just to not confuse anyone. API URL equals that. And I believe both were in quotes. Yeah, both are in quotes. So now we've got our env file. I'm going to make sure that I save it with Command S or Control S if you're on Windows. To actually connect these to our code, we'll reference these variables in our hardhat.config.js file on step 13. So we've now added Alchemy as well as our private key to our code, but it's not actually linked to our smart contract and our Hardhat development environment at all. So next step in step 13 is where we're actually going to connect those, and we will connect it instead of the Hardhat config file. Ethers.js is a library that makes it easier to interact and make requests to Ethereum by wrapping standard JSON RPC methods with more user-friendly methods. Hardhat makes it super easy to integrate plugins for additional tooling and extended functionality. We'll be taking advantage of the Ethers plugin for contract development. Just to give you greater context here, Ethers.js is a great library, and most developers use Ethers.js. Similar to Hardhat, it is the newer kid on the block and offers a lot better library than the original Web3.js. Web3.js is another library, exact same as Ethers. Web3.js was built and written by the Ethereum Foundation, but it is a little bit older, isn't necessarily as new and up to date and updated as Ethers. I also believe Ethers is a smaller package and it's more extensible. So most developers will use Ethers.js. There are some times where you'll want to use Web3 over Ethers, but 99% of the time you're going to go with Ethers. So we're going to copy this command and install it in the command line. Paste enter. we're just going to get out of this just so that we're not like waving public key and an API key around. We'll also require ethers in our hardhat.config.json or .js. Now we're going to update our hardhat.config.js. Hardhat.config.js is where everything ties together. This config file is very important for deploying your smart contracts to the right place. I would say when I'm writing and deploying smart contracts in my day-to-day, this file is getting checked and updated very regularly. I'm always making sure I've got the right API key in there, making sure I've got the right private key in there so that we're deploying it from the right account, making sure that we've got the right RPC URLs, because sometimes RPC URLs will go out of date and will get deprecated. There's a lot of reasons you would need to modify stuff inside of this hardhat.config.js file. Yeah, so let's open up ours. So here's what we got. It looks like we're importing hardhat waffle. We're just printing a list of accounts, and then we're exporting that. We're using 0.8.4 Solidity, which is not the same as what we're using in our smart contract, which is 0.7.3. So we can see that over here we are using Solidity 0.7.3, and we want to make sure that those version numbers of Solidity match up. So let's take this, we'll copy this, and we're going to overwrite everything inside of this file with our new exports. So let's talk about what we're doing here. We are importing our .env config. This is going to import our .env file, our environment variables file. We are then also importing ethers hardhat, which is going to let us use the ethers library. So then we're getting our API URL and our private key from process.env. So you need to make sure that this variable matches the name you have in your .env file, because this is going to look for this exact spelling and it's going to pull it out of your .env file. So both API URL and private underscore key need to be spelled the exact same, or else this won't work. Our default network is not going to be Ropsten, it's going to be Kovan. So we need to make sure we update our default network to Kovan. And then down here inside of networks, we're going to change Ropsten to Kovan. So now we've got our API URL. This should be our Kovan. Yep, this does say Kovan. So we're going to verify that it says Kovan. And then we are exporting our private key, and it's going to append that 0x on it so that it appears just like a normal private key would. We should be all good to go here. Let's save this. Now let's check out our tutorial again. So let's compile our contract. When you deploy your smart contract, you're not deploying the actual Solidity code. You're going to deploy a compiled bytecode. So that's what we're going to do now, is we're going to compile from Solidity into the bytecode. So we're just going to run npx hardhat compile. Super simple command. npx hardhat compile. And this is going to compile two smart contracts, both the greeter that came standard as well as the hello world. And if you're like me and you do have this greeter contract, you'll see that it'll throw an error that says, hey, you're trying to compile this smart contract with Solidity version 0.8.0. However, in your hardhat.config.js, you're specifying your Pragma Solidity version at 0.7.3. So, two options that we can do here to fix this error. Option one, we can update our greeter.soldoc to use Solidity version 0.7.3. We could do that, but it seems off topic from what we're trying to do. I didn't create this greeter file. I really don't care about it. So then option two is to just delete the file so that we're not even trying to compile it. We're going to go with option two so that we just delete the file. So we're going to just delete greeter.sol so that we're not even trying to compile it anymore. Let's now try to compile again, and we should see a little bit different. So we're downloading our compiler. Now we are doing the right stuff. Downloading the compiler, then we'll compile our smart contract. While we're waiting, I'm going to go ahead and check out what the next step is. You might get a warning about license identifier not provided. Don't need to worry. You can always message the Alchemy Discord. They're super helpful in the Alchemy Discord. If you do have issues and you need help from Alchemy, highly recommend joining their Discord. I am in their Discord, and when I have issues, I reach out to them. Elaine, the person who wrote this tutorial, is active in the Alchemy Discord at time of recording. Highly recommend, if you hit any issues in your blockchain development, you're going to just click on this link. It should open up an invite for you to join their Discord. And then from there, just message in their support channel. Or if you have a specific chain, they even have specific chain support channels. Ping them there, and you will probably get... Oh, that's funny. And you will probably get their attention within 24 hours. If the link is invalid, then you'll just look up Discord Alchemy. and then it should take you to the right place. There we go. Okay. Yeah, and there's her name again, Elaine Halpern. So, yeah, that's how you would join their Discord. Let me clear out some of these tabs we're not using anymore, so we have got a cleaner development environment. And let's check in how we're doing on our compilation. Looks like we are still downloading our compiler. So I guess we'll just be patient. While we're waiting, we can write our deploy script. I don't think we need to sit here and wait, so let's keep moving forward with our deploy so that we're not wasting your time. If we finish step 15 and we still don't, if we're still waiting, then we'll just be patient and wait, but I don't want to waste any students' time. So next up, we're going to write our deploy script. So we've been compiling our smart contract, but once we compile it, we'll actually want to deploy it from our local machine onto the blockchain. And we can do that. What's going to happen when we run our deploy script? JavaScript is going to read our deploy script, which you can see right here. JavaScript. That will then read and try to deploy. Deploy is going to check that we have a private key inside of our environment variable, and it's going to insert that private key. And once we insert that private key, we're then going to use that Alchemy RPC to actually tunnel through to the blockchain and write it there. Because from our local machine, we need to make a connection to a blockchain node. Blockchain is not a centralized server like AWS, Google, and other Web2 providers. With blockchains, instead of having a central provider where you can just write directly to the server, you have to find one random miner. Because in blockchain development, it's just a decentralized network of miners all over the world, and you need to communicate with one of them to say, I'm trying to write to a blockchain. Will you, the miner, please accept my transaction, accept my gas payment, and then write what I need to write to the blockchain for me? In order to find a node and to communicate from our local computer to that node, we need an RPC provider. That's what Alchemy is doing. We are sending our request to Alchemy. Alchemy then goes out and finds a miner, communicates with that miner, submits the transaction to that miner, where it is then processed and put onto the blockchain. Hope that answers any questions you might have about the difference between the wallet, the RPC, and our local development environment and how they interact with each other. But if you have more questions, reach out to me, reach out to the Alchemy team, look up other YouTube videos. There's lots to find on the topic of RPCs. Okay, so we're going to write, time to write our contract deploy code. So we're going to go to the scripts folder and create a new file called deploy.js, and then we're going to just make this main function inside of it. So we'll go back over to our code. We're going to open up our scripts file, and now we don't have a deploy file, so we're going to make a new one, deploy.js. And inside of here, I'm just going to paste what we got and save. Let's take a look at what's going on here. We're defining a function hello, or we're defining a function main, and then we're calling that function main. So let's look at what the function main does. It looks like we're declaring a hello world constant, and inside of that, we are waiting while we use ethers to get our hello world smart contract. After that, we're going to start our deployment where we define a new constant, where we are waiting that hello world variable, which is just our hello world smart contract. We're going to deploy our smart contract with the initial value of hello world. Remember, when we deploy, we need our constructor to have a value for the initial message. So that initial message is being passed here inside of our deploy.js function, and that initial value we're going to set our message to be is hello world. We're then going to log whatever the address is of our contract once we deploy it. And that's it. That's the entire function. Then we're actually calling that function down here, and we're just calling the main function, and then it looks like we're exiting some processes and logging any errors that we have. Fairly straightforward. Nothing too complex in here. How are we doing? Looks like we finished compilation and it was successful. We did get that warning that they told us about, that Elaine told us about in the tutorial. We don't need to worry about it. Let's just keep moving on. So heading back over to the docs, we have now, okay, it looks like they're also going to explain it, so we'll read their explanation as well, not only to refresh my knowledge, but also to fill in any gaps I might have had in my explanation with Elaine's from Alchemy. Hardhat does an amazing job of explaining what each of these lines of code does in their contracts tutorial. We've adopted that explanation here. So, a contract factory in Ethers.js is an abstraction used to deploy new smart contracts. So, hello world here is a factory for instances of our Hello World contract. Using the Hardhat Ethers plugin, Contract Factory and Contract instances are connected to the first signer by default. A signer is an account, and our account is configured inside of our hardhat.config.js. So when it says it's going to use the first signer, it's going to use the first account inside of this config. Next line, hello world equals await hello world on a contract factory will start the deployment that resolves to a contract object. This is the object that has a method for each of our smart contract functions. And on top of that, it's also going to include the address of the contract, which is what we're able to look at because we're saying hello world.address. So that's going to log out the address. We could also print out the methods that exist inside of this hello world by doing, I believe it's hello worlds.methods in the methods. It could be wrong though, and I might be thinking of Web3.js, but that's the kind of thinking you would go down to pick apart the hello world contract object to get the individual attributes and functions. So let's now deploy our smart contract to the blockchain. If this is your first time deploying a smart contract onto a blockchain, sit a second with this excitement. This is a very big moment. What you're about to publish is going to be published forever. No way to delete it. So once you publish this, it's going to be live on a blockchain forever. Very big step if you've never done it before. No need to worry. There's not going to be any negative repercussions. This is all funny money. It's not going to impact anybody negatively. It's all on a test net. But if you haven't done it before, this is a big step. And I just want to accentuate how big of a step it is, because instead of just moving forward and pretending it's nothing, the first thing you do on Web3 is a big deal, because if ever someone asks what is the first thing you did, you can always trace back on a blockchain to the first transaction you ever did and say, this is the moment I first started building on a blockchain. And for me, that was important, and for you, it's just something to be aware of. So now let's deploy. npx hardhat run. We're then going to run our deploy script, and we're going to specify the network that we want to use. So how we're going to do that is npx hardhat run. Now we want to specify what script we want to run. So inside of our scripts folder, we want to run the deploy script. And you might not be able to see what I'm typing now, but after that, we're going to do --network Coven instead of Ropsten, because remember, we're deploying to the Coven network. When I hit enter, we're then going to start that deployment process onto Coven testnet. Fingers crossed that everything goes through right. There's always a chance for errors. If you do hit errors here, reach out to me on Twitter at @sweetman_eth or Elaine Halpern on the Alchemy team on the Alchemy's Discord channel. If you're watching this on YouTube, reply in the comments, but I don't check the comments often, so it's much better to join in on Discord or message me directly on Twitter. Now you might be wondering, why is this taking so long? It's just sitting there. We're not seeing any progress bars. What's going on right now is we are waiting for this transaction to be mined. So we're just waiting for, we've submitted this to the blockchain. Alchemy is working on it, and now we're just waiting while it gets deployed onto the blockchain. I'm sure they're telling us to go and watch the Alchemy mempool explorer right now so we can see these transactions going through in real time. I would rather just sit here right now, and then in a couple seconds we can redeploy to a new contract address in a second. But there we go. It just finished deploying, and it spit out this contract address. What we can do with this is we can go over to a blockchain scanner and then verify that it was published. So I'm going to go to Coven block scanner. That should take us over to coven.etherscan.com. There it is. Yeah, so coven.etherscan.io. Now I can look up this address I was given, and I should get a transaction. It says like a couple seconds ago or a minute ago it was created. So we'll paste that contract address. We will hit enter to search, and then it should update our URL and take us over to this contract. My computer is definitely running the slows today. There we go. And it looks like we had our contract creation was 56 seconds ago, and it was created by me. This is 35CE, which should match my public key that exists inside of MetaMask. 35C ends with 0E8F. We can't see the ending 0E8F, so this is from me. I did publish it, and now that contract has been created. Let's jump back over. So we've now deployed a smart contract onto a blockchain. Great work. If this is your first time, congratulations. If you did hit an error, I'm sorry, errors happen. Don't let this stop you. Keep pushing forward. Message me, I'm here to help. Message the Alchemy team, they're here to help. We all want to help you get over this hump. Please don't let it stop you. Reach out to someone for help. Google an answer. Reach out to an actual human. We all want to help you. The faster you get into Web3, the more you can explore. Don't let this stop you if you did hit an error. You should get something like that. We did. Copy and paste this address and save it somewhere. We'll be using this address later, so you don't want to lose it. Go to the Ropsten Etherscan. This is exactly what we did, and search for the contract address, and you should be able to see that it was deployed correctly. This is exactly what we just did. We went over here and we can confirm that it was deployed. So it looks like they recommend that we do the exact thing that we just did. From address should match your MetaMask account address, and the to address will say contract creation. But if we click into the transaction, we'll see our contract address in the to field. Congrats, you just deployed a smart contract to the Ethereum chain. To understand what's going on under the hood, let's navigate to the Explore tab in our Alchemy dashboard. So let's go over to the Recent Requests tab. And we are in our Coven app right now. And when we refresh, before we didn't have anything here in the Recent Requests. But now we've actually used this RPC, and here's everything that's going on when we were running that, and our transaction was sent from our local computer through Alchemy onto the Coven testnet. This is everything that Alchemy did behind the scenes while we were just sitting there watching our terminal. First thing it did, estimated gas. We got the latest block number. We checked out the fee history. We got transaction counts. We looked up the chain ID. We sent a raw transaction. We signed it with our private key. We checked out the chain ID. And then we got the transaction by hash. We got the block number. And then we got the chain ID. And there's probably more transactions in here that I didn't even see all of. No, that's all of them. Yeah, so that's everything. This is everything that it did. And you can look through this on your own Alchemy account if you want to expand. You can see exactly what these requests look like what was sent. And then I guess you can even take them over to the composer and you can fire these yourself and see if you get the same values back if you really want to play around here. But if you want to look deeper, you can. I'm going to keep moving forward. You'll see here we have a handful of JSON RPC calls that Hardhat and Ethers made under the hood for us when we called the deploy function. Two important ones are send raw transaction, which is the request where we actually write our contract onto the Ropsten chain, and ETH get transaction by hash, which is requested to read information about our transaction given a hash. To learn more about sending transactions, check out the tutorial. That's all for this part. In part 2, we'll actually interact with it. But that's it. We finished. We have deployed our smart contract, our Hello World smart contract, onto the Coven testnet. If you've got any questions, again, reach out to me on Twitter at sweetman_eth. Reach out to Elaine on the Alchemy Discord, join the Alchemy Discord, or just run Google searches, watch other YouTube videos. Keep exploring, keep asking questions, and I guarantee you the answer is out there. You will be able to figure it out. Yeah, that's it. Next lesson, we're going to go into lesson 2. The next section, we're going to do the same lesson but using Truffle. If you've gone through on Hardhat, you don't need to go through on Truffle, so you can just skip that section if you've already done the Hardhat stuff. If you do want to learn how to use the Truffle tools, just as we're using the Hardhat tools, you can. Not required. Personally, if you're trying to go for speed and just trying to get your first job in Web3 as fast as possible, just learn Hardhat in my opinion. If you're just kind of exploring this space and you're more as like a hobbyist and you're really trying to learn everything, take the time and be a generalist and learn all the tools, Truffle and Hardhat. Up to you though. You're the one that's making your path. You're the one that's figuring out the type of person you want to be as an engineer in the Web3 space. I'm just here to try to help you along the way. Hopefully this was helpful for you. Again, already told you how to ask any questions. Thanks for tuning in. This is sweetman.eth signing off.